It was in my second year at the University of Georgia. It was in the spring, April of 1974. I was listening to a baseball game on television. And it was sort of an exciting event. Hank Aaron of the Atlanta Braves had already tied Babe Ruth's career home run record of 714. And everyone was just wondering when he was going to hit number 715. It was sort of like this year when Mark McGwire hit number, 60? What was the record breaker, 63? 62 was the record breaker? Right. So, yeah. So it was sort of like everyone was wondering when he was going to break Roger Maris's record. So on that day, Hank Aaron did it. He broke it. And, you know, everybody knew these numbers. They were talked about. You didn't have to say Hank Aaron. You didn't have to say Babe Ruth. You didn't have to say baseball. Anything. The numbers themselves carried the meaning. Everybody knew what 714 and 715 meant. Now, I'm a number theorist. And so I said, okay, if these numbers are so gosh darn important, you know, why are they interesting as numbers? So I factored them. And they factor real easily. 714 factors as 2 times 3 times 7 times 17. And 715 factors as 5 times 11 times 13. And look at that. What you see here in these two consecutive numbers are the first 7 primes. So that seems like a pretty strange property for two consecutive numbers to have, that their product should be the product of the first k primes. Now, there are smaller examples than this. For example, 14 times 15 is 2 times 3 times 5 times 7, or 5 times 6, or 2 times 3, or 1 times 2. But those are the only examples, probably. Probably 714 and 715 is the largest example of this. It's not been proved. Anyway, the next day I went into work, and I saw a colleague of mine, Dave Penny, and I said, can you find an interesting property of 714 and 715? And he immediately found the same thing I found. Well, he was teaching a class in numerical analysis, and he went into his class and he said to them, can you find an interesting property of 714 and 715? And one of the students in the class found another property that we didn't find. That if you add up these primes, maybe like Pythagoras might have done, added up the prime factors of 714, what do you get? You get 29. And if you add up the prime factors of 715, you also get 29. Unbelievable. So anyway, so the three of us wrote a paper for the Journal of Recreational Mathematics. We tried to make it comical and so on. And we didn't pretend that this was a serious topic. And we wrote the paper about these amusing properties of 714 and 715. And what we did is we said that a pair of consecutive numbers was a Ruth-Aaron pair if the sum of the prime factors of n is exactly equal to the sum of the prime factors of n plus 1. So for example, n equals 714 works here. So we did a computer search. We found lots of other examples, larger ones than 714 and 715. And we conjectured that they have density 0. That it's an unusual property. Obviously, it's unusual, but could you prove it's unusual? We didn't know how to prove it. Well, guess who was a reader of the Journal of Recreational Mathematics? But the great Paul Erdős. And he wrote me a letter. I want you to remember, I was an assistant professor at the University of Georgia. I was not well known at all. I would never have been invited here for the Porcelli lectures, for example. And here's the great Paul Erdős writing me a letter. Think about it. He said, I know how to prove that these numbers have density 0, and I'd like to come to Athens and discuss it with you. Of course. So he came to Athens. It became the subject of our first joint paper. And that's when my real education began, as I told you at the beginning of my lecture. Since then, we wrote 19 other papers, and it completely changed my life as a mathematician. But so let me just show you there's still actually an unsolved problem here. The problem would be that not only do they have density 0, but they are very sparse, that some of their reciprocals is convergent. we haven't been able to prove that. That's still an open problem. But I'd like to tell you the final note of this story. Erdős received many honorary degrees, especially in the last few years of his life. And he received an honorary degree a few years ago at Emory University in Atlanta. And there was a party the night before graduation for the recipients of the honorary degrees. And each recipient got to invite a few people to this party. And so Erdős invited me to this party. And I was there with a few other mathematicians from Emory. And on the way over there, one of them was telling me, I asked who else is getting an honorary degree other than Erdős. And they said, well, maybe, there's a pretty famous baseball player getting an honorary degree also. It's Hank Aaron. I said, what? Hank Aaron? I mean, this is how I met Erdős in the first place. So it just seemed like a tremendous kismet that this should happen. So, in fact, the Emory people didn't know the story. They didn't think anything was remarkable that Aaron would be in the same place with Erdős. But I thought it was, personally, to me, was extremely remarkable. Ron Gould from Emory had some baseballs with him for Aaron to sign. So he gave me one of the baseballs, and I had Aaron sign it, and then I had Erdős sign it. And I have this now in my office. So it said if you have a joint paper with Erdős, you have Erdős number 1. So I figure that Aaron, he doesn't have a joint paper with Erdős, but he's a joint baseball. Anyway, I went over and told Aaron the story, and he thought it was sort of funny. And then I introduced him to Erdős, and Erdős asked him about why he quit baseball, and Aaron said it was his knee, and also that he was losing his reflexes. And so he was amazing that this man who loved only numbers could speak to anybody and carry on a reasonable conversation, which he did. So I have a photograph of the recipients here of the honorary degree. Here they are. And you can see the large gentleman in the front row. In the center is Hank Aaron, and maybe you recognize this guy over here with the glasses. That's Uncle Paul Erdős. So thank you very much for your attention.
Any questions? I'd like to make a brief comment. Erdős visited LSU numerous times, and I had several occasions that I entertained him in my home. And I asked him one time, I had heard that he had never had a job at a university. He traveled around the world giving lectures all over the world, but I had heard that he had never actually held a job other than temporary lecture or something. And I asked him if that was true. And he said no. He said, I was employed at the University of Notre Dame one time. And I said, oh, and did you stay long? And he said, no, I quit. And I said, well, why did you quit? And he held his hands up like this, and he said, there were too many plus signs on the wall.
Actually, there's a real story about why he resigned his position there. This was in the early 50s, and this was in the heyday of the McCarthy era. And he was from a communist country. He's from Hungary. And he was not a refugee. He just, he didn't care to renounce his Hungarian citizenship. And so therefore he was looked at with great suspicion by the US government that here was somebody from a communist country who would not be a refugee from the communist country. And they said, okay, well, you can stay in America so long as you never leave America. If you leave, you cannot come back. Well, Erdős is not a citizen of any one place. He was known as a citizen of the world. And as soon as the first opportunity came up for a mathematical conference somewhere else, he didn't care about Uncle Sam. He went to that conference. And of course, Uncle Sam was true to his word and didn't let him back. And it was quite an effort of the American mathematical community to get him back to America. It took about 10 years. So it wasn't just the plus signs on the wall.